All right, welcome everyone to this week's Xojo webinar. I'm Paul Lefevre, the Xojo Developer Evangelist, and this week we're going to be talking about text and encodings, as you can see by this very big slide here. And you might recall earlier in June, we talked about some of the new data types that are available in Xojo and the Xojo framework. And one of the ones we excluded was the text data type. So we're going to cover that today. And because it's very tightly related to encodings, we're also going to talk about that and look at a few examples as well. So the text type, what is it? Well, essentially, it is a modern string. It uses Unicode for storing its information. You can read its doc page here at developer.xojo.com/text. And it is available for all project types. So this is not an iOS thing, just like all the other stuff we talked about last time. You can use this in all your project types. Whether or not you're even using the new framework, you can still use the text type. Anything that is a text will automatically convert to a string for you. This is very handy when you are still using older framework classes, particularly things like UI controls for desktop and web that are still going to be using string, of course. If you have something in text, you can just assign it to a string variable, a string property, and it'll just work. You don't have to do anything special. You can also convert a string to a text, but you do have to call the toText method on string in order to do that. And that will take the string and convert it to a text, but the string must have a valid encoding. And we'll talk about more about encodings, of course. This is a very confusing subject, and hopefully I can help straighten it up for a few people. And essentially, if you create a string in your Xojo code, it's going to have an encoding set automatically. So toText on it will work. But if your string came from somewhere else, there's a chance that it does not have an encoding. Let me get closer to the mic juice to see if that improves up the audio at all. All right, I got a question here from Edwin. When I use text, when do I use text and when do I use string? Well, hopefully after this webinar, you will get a good understanding of why you'll want to use text probably most of the time. And this is some sample code here that shows you how you can convert an actual string into a text so that you can then use it as a text with newer framework methods and classes and whatnot. Now, text has lots of methods on it. I'm just going to fly through a few of them here. We'll look at some code in Xojo that shows how to use these methods at the end. But just to give you a teaser or a taste of what's in there, there's begins with and ends with that allows you to check if the text starts with a particular set of characters or ends with a particular set of characters. There's also two iterators, characters and code points, that let you iterate through all the characters in your text. And you can also get back the Unicode code points for the characters that are in the text. There's a compare method that also, of course, can compare using Xojo's native case-insensitive comparisons, or you can do case-sensitive comparisons. And begins with and ends with also have the ability to do case-sensitive comparisons. There's a method to quickly check if text is empty. There's a length method, of course. The index of allows you to search the text for other subtext. The typical left, mid, and right methods to pull out chunks of the text. The lowercase methods, or the case methods, lowercase, title case, and uppercase. And of course, replace and replace all allow you to swap out what's in the text. Split and join allow you to split text on a delimiter and get back an array. And join allows you to take an array and combine it into a single piece of text. And then there's trim methods. And a lot of these are pretty familiar. They might work a little bit differently, but like I said, we'll look at some actual code in Xojo at the end for how all of these work. Oh, and of course, the new one is from Unicode Code Point, which won't make much sense to you right at this moment, perhaps, but we'll be talking about Unicode a little bit later, and you'll see how that can be used. So why is text needed? Well, it's primarily because string serves too many masters. A string can contain text, and if you create that in your own Xojo code, that text would have an encoding of UTF-8 by default. But a string can also contain binary data, and it doesn't really differentiate between the two. Now, you might think, well, who cares? Well, 20, 30 years ago, probably it didn't matter so much. But these days, it starts to matter a bit more, especially with lots of different languages, character sets, and things like that. But this results in, you may have a string that doesn't display properly. You may have seen this from time to time as black diamonds, these little diamond characters with a question mark that appear in the middle that sometimes will show up in strings that you're trying to display. That indicates you have an encoding issue that you obviously were not aware of. This can also lead to bugs with string comparisons, because if your two strings don't have the same encoding, or one of the strings doesn't have an encoding at all, string comparisons are not going to work the way you think they are. And that can lead to really hard to track down bugs. And if you want to read a little bit more about this, I highly recommend this forum post by Chemtech and I that he wrote about a month or so ago. He had some grand epiphany in the middle of the night, according to him. And this is a great summary of strings and how they came to be and why they work the way they do, and text and how it kind of works. So I encourage you to, after you're watching this webinar, take a few minutes to read that forum post. But essentially, the text type is going to deal with your text, and you don't have to worry about encodings. Text contains text. Nice and simple, like that. Now, a little bit of background about encodings, because this is where some of the confusion starts to show up. Now, you have text. You have some string of characters, and that's how string got its name, because it essentially was characters kind of strung together. But you've got something, a word, a phrase, or whatever. So how do you represent this? Well, way back at the beginning of time, one of the first things that was used was something called ASCII. I forget what it stands for now, American Standard something or other. And it used a 7-bit format to store 128 different characters, pretty much all the English alphabet, bunch of punctuation, stuff like that. And it was used for a really long time. Eventually, it bumped up to 8 bits, so it could use a full byte. So then you had 256 different characters. But the problem was that extra 128 wasn't always standard. So you might have some version of ASCII on one computer, that platform, that wasn't compatible or wasn't the same with some version of ASCII that was used on another computer platform. This was particularly problematic in the beginnings of personal computing in the late 70s and 80s. When pretty much, there was a wide variety of computers, and they all pretty much had their own version of ASCII. And like I said, for just English text, this isn't the end of the world, but the world is big, and there is more than just English text. So this became a problem, and people started coming up with different ways to represent the text, to encode it. And eventually, sometime in I think it was around 2000, maybe a little before, maybe a little after, Unicode was put together. And this is a way to track pretty much any character in any alphabet in any language, in addition to lots of other symbols, emoji, for example. This Unicode can hold something like some million number, but it contains, I got another slide that'll show some of the other numbers. But so the important thing is to understand that we're now in the age of Unicode. Now, the other thing to remember, I brought this up before, is that in Xojo, string never required an encoding. In its initial days, that made sense, because a string was just, essentially a string of characters, and a character was a byte. So, it all kind of worked that way from the computer's perspective. But encodings are needed when you have to deal with larger character sets. different languages, stuff like that, because you have to know how to represent a character that might have an accent over it, or a character that's not in the standard US alphabet. And because string could contain binary data, it really, you could end up with strings that didn't know what they contained. So if you assigned something to a string, you may personally have thought it was some text, and that's great. But if the encoding wasn't correct, when it came time to display what you thought was regular text, it wouldn't display how you expected, because it couldn't decipher what was in the string. And it might have just displayed it. You might have put some data in there that was in, an encoding format, such as, say, a popular one for, I think, Mac OS 9 might have been Mac Roman, which was just a Mac encoding format for a bunch of characters. And if you try to display that using some other encoding format, it's just not going to display the way you want, because the characters won't be in the same positions, won't have the same identifiers. So things can get messy. Now in Xojo, going forward, the text type always uses Unicode. Everything is Unicode. So you don't have to worry about encodings when you're dealing with text. If you have the text, you know it's Unicode, you know it works. And you can't put binary data in text. So you can't end up with something in there that could possibly be displayed badly. And if you want to manage binary data, well, you use something that is suited for it, which is a memory block. Now, Unicode is an internal representation of information. So let's talk a little bit about that. It's industry standard for text representation. I talked a bit about, here we go here. There's over 120,000 characters in Unicode. It can contain a lot more. I think when I was reading some of the pages on this, there's over 1 million different things it has in it. In addition to characters, there are symbols and there's emoji. I bet emoji is starting to take up a majority of what's in Unicode in this day and age. But it has everything. And these things are all tracked using what's called code points. And generally speaking, you're not going to specifically have to worry about these sort of things, but I'll show you how you can look them up in case you're looking for specific characters. And you can kind of think of code points as equivalent to, back in the ASCII days, using the ASCII value. So what was the ASCII value of the capital letter A? It was 65 decimal. So code points are essentially the numbers that equate to specific characters in the Unicode system. Now, I'll just have some links here for reference later when you grab the slides and want to click through things. But of course, Wikipedia has a big thing on Unicode. Unicode.org has lots of information as well. And UnicodeLookup.com is one of many, many sites that I found that allows you to look up code point values. So you can scan through Unicode, pick out a specific character that maybe you're looking for or want to use. You can get its code point, which allows you to use it in Xojo code. So here's some example of Xojo code that is using Unicode code points. And you can see the first example is using a literal. So that &U means we're going to put in a hexadecimal Unicode code point value. So E0 there is the code point for this A with the accent grave over it. And if you have the decimal value, you can also call the from Unicode code point method on the text type and just pass that in. And in both cases, you get the A with the accent on it. So that's how you can use code points should you want to. And again, depending on, you may never even need to touch these things, but this is just a background for how they would work. Now, as related to the question that I have sitting here in front of me from Edwin is, how do we figure out how many bytes will be used when saving stuff to disk? Well, you don't actually save Unicode to disk. You have to encode it in a particular format. And the Unicode encoding formats are UTF-8, UTF-16, and UTF-32. There are, of course, a bajillion other encoding formats. You can certainly scour the internets for lists of them. Some of them are going to be very specific to maybe older computer systems or operating systems or databases or something like that. There's, again, more Wikipedia information for people that like to dig deeper. But these days, by and far, UTF-8 is the most widely used encoding for most of your textual data. So this is the one you're pretty much going to want to stick with. And a nice thing about UTF-8 is that it is backwards compatible with ASCII. There's an incredibly clever way that they implemented UTF-8 so that it's able to be backwards compatible with ASCII and also be relatively space efficient. So it doesn't require, say, 32 bytes for every character. It's able to use fewer bytes for certain characters and more bytes for other characters. And that obviously is preferred over always using the maximum amount of bytes for characters that don't necessarily need it, which is what the other UTF types do. So they're not quite as space efficient. Now, after you finish with this webinar, I'm going to recommend that you take about 10 minutes and sit down and watch this computer file video on YouTube, Character Symbols and the Unicode Miracle. And this is the link here. I'll have it again at the end, but you should definitely, I'm sorry, that's a silly YouTube link with weird characters, but maybe you can Google it. But I cannot recommend this enough. It's only about 10 minutes. Very personable fellow, talks to you about Unicode, why it was created, and how it's able to be space efficient using a very slick technique. And it's definitely worth your time to watch. So when do you need to care about encodings? That's really what it all comes down to, right? Well, when do I need to care about this stuff? So you need to worry about encodings anytime you're dealing with data that wasn't created by your app. So this can be information that comes from external files, stuff that comes from internet communications, databases. All of those are primary sources of data that your app didn't generate itself. And the reason you need to care about encodings is because all of those things could be encoding the text in different ways. It's possible they're using UTF-8. That would be ideal. That's the most common one, as we talked about. And but it's also very possible they're using something completely different. With files and internet communication, that is not quite as likely these days, unless you're getting, some older files that have been around a really long time. Internet communication, I think I saw some stats that said most web traffic these days, like something like 80%, is all UTF-8. Databases, however, could possibly be a more significant source of trouble because databases may have been around a long time when the original database was created, particularly if it's a database server. It's possible it was even created before any of the UTF formats were available, so it could have a completely different encoding format. So the thing is if you're getting that data from the database, you need to know what format it's in so that you can appropriately convert it into your Xojo app and use it properly and get all the characters that it's represented and not end up with those little black diamonds or a bunch of gobbledygook. So how do you specify encodings? Well, in the new framework, there is a text encoding class, which you can find at that location. And it serves a few purposes. It allows you to get an encoding for use by other methods. And we'll look at some examples of that here. It has some built-in shared methods for common encodings. Again, UTF-8 is quickly available as a shared method, and that's one of the most common ones. There's I think the other UTFs are also on there, and probably ASCII. You can also use this class to convert binary data to an encoding. And this is useful for data that's received from an outside source, so you can convert data to text using a specific encoding. And then once it's in text, you don't care about the encoding. Unlike with string, you always had to care about what encoding the string was. Once you get your text, into a text variable or whatever, you don't have to worry about the encoding at that point, because once it's in text, it's in Unicode. And everything is happy at that point. But you do have to get it into text. And in the other direction, you may have some text that you need to get into binary data so that you can do something like transmit it. It could be probably the most cases I've run into this is transmitting data over like a HTTP socket or something like that. But I suppose you could run into this sort of thing if you were communicating with specific types of databases, or if you had binary files or something like that. And for that, you call the convert text to data method. So with text files, you must specify the encoding when you're reading or writing to the file. So here's a little code snippet. And you can see here, the important line of code is the open, the call to the open method near the bottom there. And that's going to open a file. And the second parameter is the encoding of the file. So I'm saying I want to open that file, and it is UTF-8. And that allows that file will now be opened. It'll be processed as if it contains UTF-8 encoded text. And then it'll be assigned to, in this case, I'm assigning it to just a text area. But it's assigning it to text. And then that process will put it in text, and then it's Unicode at that point, and I don't care that it was originally UTF-8. Now that it's text in Xojo, it's text, and I can just do whatever I want with it. And then when I'm ready to save it back to a file or send it over the internet or put it in a database, I can encode it down to whatever format I need. And for most of your things, by and large, you're just going to be sticking with UTF-8. So that part is nice. You're not going to necessarily have to worry about 50 different encodings, but you are just going to have to be thinking about, all right, the data I got came from somewhere. What is its encoding? And now I want to put it out, and what output do I want? And unless the system you're outputting to has some specific needs, you're almost always just going to want to output to UTF-8. Same sort of thing here. When sending or receiving data, you're going to have to encode it in some manner. This is a little code snippet from a page received event handler in an HTTP socket. And you can see here that it is calling the convert data to text method. Page received supplies as one of its parameters content as a memory block. So the content of the page is stored in this content parameter, and it's a memory block. But, most of the time that's just going to be UTF-8 data. So I can just here create some text. I call it response, and I can say, all right, I want to take a UTF-8 encoding, call its convert data to text method, and convert the binary content. So that essentially is taking the binary content data and converting it to text, assuming that that binary data is text that was encoded with UTF-8. And then again, once this step is done, I now have this response variable, and it just contains text. I don't care anything about what its encoding originally was. It's now in text. It's Unicode. I can do whatever I want with it. All right, the last one I want to show you here before we jump into Xojo is databases. Now, they often use UTF-8 by default, in particular SQLite. But as I mentioned, other encodings can also be used. And in my experience, I've mostly seen other encodings when you're dealing with database servers. So that's the thing you want to check. Again, this is sort of almost an admin setting on the database server. It may or may not have UTF-8 set up as its standard encoding to use. So that's just something to keep in mind. Now, this sample code here is using a mixture of old framework stuff and new framework stuff, because most of the database classes are, well, actually all the database classes that you would use with web and desktop and console projects are using the old framework. So they can still use strings. the SQLite database class for iOS uses text because that's all new. So you can mix and match quite readily. It's not a big deal, but you do got to do the steps appropriately. So this is just a code snippet again, but I got a record set somehow, and I want to grab the field, the information that's in the field column for this particular row. So I assign it to DB data, and I want the string value. Now, I want to specifically define the encoding on that string value. It may or may not be UTF-8. If you're coming from MySQL, there's probably a pretty good chance it may not be anything. It might be a blank encoding. I think our MySQL plugin might leave the encoding as blank. So you want to set the encoding immediately on the next line. I'm saying, all right, I need to specifically tell this string that it has specific encoding. And I can't quite see which my sample code here has. So yeah, I have it. I don't actually have it here set as UTF-8. I have it as another random encoding I picked, but ISO Latin or something. But these are the things you have to know is, all right, well, what is the encoding that's used by the database I'm connecting to? And specifically tell the string, hey, string, data, this is your encoding. And now you've done that simple little step, you can just assign that string into text. As I've done here, text data equals the dbdata.toText, and that converts the string, and because it knows it's encoding, it converts it over to text, which is Unicode, and now you can use it however you want. So as you see, I keep saying over and over, the trick is to get it into the text, and then you can use it however you want. And you don't have to worry about encodings at that point. You just, write your app, work with your stuff, and then only at the points, the input and output points of your app, do you have to worry about encodings. So it simplifies things a little bit there for you. You still have to understand encodings, but you don't have to deal with them nearly as often. All right. All right, before we jump into some Xojo code, I'm going to, again, put up the links I recommend you take a look at. I mentioned Kem Tech and I's string and text forum post, which I did refer to myself in putting together this webinar today. So I do recommend reading through that. It's not super long. I also highly recommend this video on the Unicode miracle. It's fun. They talk with this dude, and he appears to be sitting in a restaurant while he's talking and drawing doodles on napkins and stuff, and yet it's all very effective. Apparently, this fellow does all kinds of computer tech stuff. It's quite entertaining. And then we also have a blog post that we had on the Xojo website. Why are there black diamonds in my user interface? And this talks a little bit about what happens when your encodings essentially get out of sync and why these black things appear. And it's essentially they're appearing because your encodings aren't matching, and it doesn't know what the value is. If you've got a value in that ISO Latin and it doesn't map to anything in UTF-8, well, what are you going to show? Turns out this black diamond is something that typically gets shown. All right, let's switch into Xojo, and we'll take a look at some of the text method examples. All right, so here we have, much like I did with the framework stuff, a bunch of code here. And what we're going to do is I'm just going to run it, and we'll step through it in the debugger and look at the results. So let's do that. All right, so we got our debugger here, and we'll just step through. So the first thing, very simple text assignment. You can see these things in the debugger, just like you can with anything else. And now we'll check. All right, does this text begin with hello? And yes, it does. It returned true. Now does it begin with hello lowercase? And that is still going to be true because normally Xojo does case insensitive string comparisons. Now this last one, we can tell it, well, we actually want to be case compare, have our case sensitive comparison here. So I can call begins with, but I can pass in the optional constant and say, hey, now I want you to be case sensitive. And when I do that, you can see result is now false because it does not begin with lowercase hello. End with works exactly the same. Nothing too thrilling there, but it just checks the end of the string, or end of the text. Characters and code points are iterators. You might remember from the last webinar that iterators allow you to use for each to loop through the values. So in this particular case here, you can use the characters iterator to just loop through all the characters in the text. So here I'm just looping through, and I'm just going to append them in essentially reverse order here, and you can see the text will end up being built. I'll go through here a bunch of times backwards. So if you ever need to iterate through the characters individually in your text, you can easily do it just using a for each on the characters iterator. Similarly, if you ever need to iterate through the code points of the characters in the text, you can use the code points iterator. And you can see here the code point values for each of the characters that are in there. And part of the design of Unicode is that the code points for the characters that would have been in ASCII are the same. So code point decimal 65 would still be capital letter A, for example. So that is good. You don't have a whole bunch of different things to worry about. But code points can vary quite a bit for other characters, accented characters, emoji, other symbols that you don't typically see on a keyboard. Stuff like that. Let's jump ahead here. All right, so you can also compare. And compare works as before. It returns an integer that tells you whether the text is the same or less than or equal. So you can see here, compare result. We compared hello world to the original string, which is hello world. It's a case insensitive comparison, of course, so it's returning 0, meaning they matched. If I compare it to ABC, it's going to return 1 because the original text of hello world is greater than ABC. And then if I compare it to Xojo, it's going to return -1 because the original text of hello world is less than Xojo. The empty method allows you to quickly check if text is empty. So you can see the result here is going to be false because our text of hello world is not empty. This is, I'm told, faster than doing the comparison to just, the double quote thing that people often do. So rather than doing, if t equals double quote, you can now do if t.empty. And that under the hood, so to speak, is a bit quicker. And you can see it's true when the text doesn't have anything assigned to it. Length is just the length, and that's the actual number of characters that are in the text. Index of is a search for the substring. So here it's telling you that world starts at position 7. And this is 0-based, of course, because it's new framework stuff. Left, mid, and right will work as you expect. I skipped over the left, but you can say the last 6 characters are world, and then and I grabbed just this part, world here, without the exclamation point. So that all works how you might expect. But remember the mid here, that would be 0-base. Lowercase, title case, uppercase. Do what you would expect. Now, one thing I'm not demonstrating here, but you can see when you look at the reference for this particular page, is that all of these things allow you to specify an optional locale. And that can be helpful for particular functions like comparisons and uppercase, lowercase, because some characters may not upper or lowercase quite how you expect. So you may need to specify the particular locale so that the rules for that locale are followed. I don't exactly, that could be things like, uppercasing the letter A that has an accent over it. Maybe that has some different rules in particular parts of the world. So just something to keep in mind there. Replace does what you would expect. So here the new text now says, hello, Earth. Split and join are cool. If you just call split without any parameters, it will just split the text on each individual character. So I can see here my text array now has an array, and each character is an element of the array. So that's nice and fast. And that's the way, if you need to get at, you want to get at a specific thing, specific entry in there, and you don't want to use left, right, or mid, you can just quickly split it into an array and then just access the array however you want. You can, of course, also split on a particular delimiter. So if you've loaded in a file that's, say, tab delimited, excuse me, you can just call split, pass in the code point or a text that has tab in it, and then you'll get an array that's split on the tab characters. And you can see here, fifth character is the O, remember 0 base, so 0, 1, 2, 3, 4 makes 4 the fifth character. Here we've got a text array that contains these 4 values. And join just combines them into a single text for you using a supplied delimiter. So I supplied the comma, so now I have a nice comma delimited list. Trim here is going to trim off spaces and other non-viewable characters. I think it also trims off maybe line feeds or something. And you can see here, I just put the bracket so you can see where that the spaces went away. So you can see here that it trimmed all the spaces from both ends. And then you can see it just got the left, and then it'll just grab the right and left the other ones alone. And then creating text from Unicode code points. You can call the method from Unicode code point and pass in a decimal value here. And you can see that creates the A with the accent. And you can do the exact same thing using the literal command here, &u. And then, but you have to, when you do this, pass in the hexadecimal value, not the decimal. If you pass in the decimal, well, that's going to be a completely different code point, and you might be confused. So that's a quick run through of a bunch of the methods that are on the text type. Now let's jump in and take a look at some code that's using encodings real quick, and then we'll be done. So the encoding stuff here is not too sophisticated. This is pretty much the same example as in the slides, except with error handling. But you can see here that I'm creating a text file, and that's just a file there, but I'm telling it the encoding. And that's just required. You have to tell it the encoding of the file. Now, you don't have to use UTF-8 here. Like I said, it's probably going to be the one you're going to use. It's the most common one in this day and age. This is 2015 now, but 15 years ago, this would not have probably been the most common one. But you can pick anything. It is handy to have UTF-8 available quickly as a shared method, but text encoding does have a shared method you can call and supply in it a parameter, which is the encoding name, and it'll return that actual encoding for you. So if you have a less common encoding that you need to use, you can grab it that way. But that's it. The text is the text. It doesn't I'm not telling the text anything about its encoding. I'm just saying, well, the file has this encoding. Here's the text to put in the file. And that text will be encoded appropriately so that it is a UTF-8 file, and that anything else that's expecting that will be able to process it. So pretty straightforward stuff there. And then I have the other example here from an earlier webinar that was using HTTP sockets. And you can again see here, same sort of thing. This is taking some binary data that has come in through the page received event handler. And you can see the binary data comes in here and the content parameter, and it's a memory block. But I know that I'm expecting text here. And I know that it's UTF text, as this particular example is actually communicating with a web service. And I know what the web service is providing for information. So I can create some text, and I can say, all right, I want to convert that binary data that came in to text. So I can again call the UTF-8 shared method to give me a UTF-8 text encoding. And then once I have that, I can call the convert data to text method, supply in the data, and then supply the optional parameter here, which is allow lossy. I didn't actually need to include it because false is the default. And that just means, will it raise an exception, or will it, hang on a second, I got a message popping up here and I don't know why. All right, so that allows text, if it doesn't know how to convert it, it'll essentially put in the black diamonds for you. Or you can tell it, hey, if I don't know how to convert it, raise an exception because this isn't the data I was expecting. So, but it gives you the control over that, so you can make your app work how you want it to work. And then again, once you have it in text, it's just text, and you use it however you want. You don't have to worry about encodings from that point forward until you again need to do something with the data, send it back out through another socket, save it to a file, put it in a database, whatever. All right, so that covered everything I wanted to go over here. Let me just switch over to the last page and then check any questions that might be outstanding. All right, well, Edwin here is asking, how can we check how many bytes will be used when saving stuff to disk? How would you check before? I mean, the easiest way might be to just save it and then check the size of the file. Another way would probably be to convert it to a memory block using the encoding you're going to save it to, and then checking the size of the memory block. That's what I can think of off the top of my head. All right, and Edwin is also asking why memory block is used with things like HTTP sockets rather than just text itself. And again, that goes back to the fact that, well, in the older framework of Xojo, string kind of served those two masters. It could contain binary data, and it existed long before memory block did. So some of those older methods at the time, the only way to actually put binary data would be to actually stuff it into a string. And it would have made probably more sense for those all to be updated to use memory block, but that's the sort of thing that breaks code, and we generally don't try to do that sort of thing. But that was a completely non-starter for the new framework. We couldn't have the new framework use text for something like an HTTP socket, because an HTTP socket can receive more than text. It could certainly receive binary data, if you're transmitting a file or something like that. So text wouldn't cut it. You have to use memory block. And then if you know that the data in the memory block is actually text, well, you just convert it to text using the encoding, and now you have your text. And if it contains binary data, well, then you take it as binary data and do what you need to do, write it out to a file or whatever. So that's why there's the difference there, and there's that's the way it kind of has to be. That's the way it is. Juiced is asking, what is the maximum number of characters in text? There is no maximum number of characters you can put in text. Just like with string, these things are limited just by the amount of available memory. So as of today, Xojo still makes 32-bit apps. So that your memory limit there is, about 4 gigabytes is maximum you can access with 32-bit systems, and you'd have, a little less than that. So that's a pretty big chunk of text. But there's no practical maximum to speak of. And Edwin's noting that sharing code can be trickier when dealing with text and string and some of the UI stuff, or graphics and web graphics, that sort of stuff. Yeah, and the way to do that is with the compilation target commands, pound if and then a target. That's the conditional compilation stuff. But again, text is the same throughout all the project types, so you don't really need to do any conditional compilation on text. That you can just use the same in all shared code. So that should help with any code that you are sharing in that manner. You just use text and you're all good. It'll work in all the project types. All right, I'm checking my little timer here. I don't see any other questions. And it looks like we're going to finish about 10 minutes early, and not coincidentally, that will give you the exact amount of time to watch the video that, again, I highly recommend, which is, if I can figure out how to get that page back up. Remember, watch the Unicode Miracle video. You got 10 minutes now. Take advantage of it. Watch that video. It definitely should help. And this recording, slides, and examples will all be uploaded later today. And of course, as usual, you have any questions on this or other Xojo-related topics, or you want to just, discuss Apple Music or anything else, you can always reach me on Twitter at @Lefevre, or, of course, at paul@xojo.com via email. Thanks, everyone, for attending. Have a great day.